In the previous video, we have discussed about matter and kinetic theory of matter. Also, the three states of matter, that is, solid, liquid, and gases, and the latent heat. The specific latent heat of fusion also we have discussed in the previous video. Now in the second part of this chapter, we are going to discuss the advantages of high specific latent heat of fusion of ice. The advantages are: drinks are cooled more effectively by adding pieces of ice than by keeping them in ice cold water at degree centigrade. Due to this high specific latent heat, 1 gram of ice absorbs 336 joule of heat from the cold drink to melt into water at 0 degree centigrade. Thus, cold drink loses a large amount of heat and can be cooled quickly. In cold countries, the water in lakes and ponds does not freeze at all at once. It freezes gradually because during freezing, every gram of water will release 336 joule of heat to the atmosphere, thus making the surroundings pleasant and warm. Snow at the top of mountains does not melt at once because of the specific latent heat of fusion of ice. There are many more examples for latent heat advantages. The specific latent heat of vaporization. The latent heat of vaporization of a substance is the amount of heat required to convert unit mass, that is 1 gram of the substance, from the liquid state to the vapor state without any change in temperature. The specific latent heat of steam is 2268 into 10 raised to the power 3 joules per kilogram, which means 1 kilogram of water at 100 degrees centigrades required 2268 into 10 raised to the power 3 joules of heat to convert into steam at 100 degree centigrade. Effects of high latent heat of vaporization. Steam, having a high specific latent heat of vaporization, causes more severe burns than boiling water, both having the same temperature, that is 100 degrees centigrade. When 1 gram of steam condenses, it releases 2268 joules of heat in addition to the heat released by boiling water. Thus, steam causes more severe burns than boiling water does. In cold countries, buildings are centrally heated by passing hot water at 100 degrees centigrade in pipes from the basement upwards to every room in the building. Steam is also used for running trains and machines because of the heat released during the condensation of steam is very large and gets converted into mechanical energy. Students, do you know why does clothes in summer dry up rather than in winter? Or water in ponds reduces to half the quantity over a period of time. The phenomena responsible for these process is called evaporation. Rays of sun heat up the water in lakes and ponds. Water molecule gain energy and gradually leaves the surface of the liquid in the form of vapors. This is a very slow process which takes place over days and months. The change from the liquid state to the vapor state at all temperatures from the surface of a liquid is called evaporation. Evaporation causes cooling due to the absorption of latent heat. Some examples of latent heat or evaporations are: water kept in a surhahi remains cool and fresh. This is due to the effect of evaporation of water from the minute pores present in the clay pot. When you sit under a fan or hot summer day, you feel cold. This is because as you perspire, that is, you start sweating, latent heat is absorbed from the body, resulting in cooling. And there are many other examples for evaporation, like strips of wet cloth are placed on the forehead of a person having fever, or a dog hangs out their tongue, or we feel cold after a bath. Now the next topic is change of state in matter using kinetic theory. Heat energy is involved whenever there is a change of state. Whenever a solid like an ice cube or butter absorbs heat, there is an increase in the interparticle space, and the substance expands a little as the particles gain kinetic energy. As the average kinetic energy of the particles of medium increases, the solid melts because the particles can now flow. They have overcome the force of attraction and have become liquid. Melting or fusion. Melting or fusion is the change of state from solid to liquid by the absorption of heat energy, what we have already discussed in the previous part. Melting occurs at a fixed temperature. For example, ice melts at 0 degrees centigrade, whereas wax melts at 54 degrees centigrade. As there is an increase in the energy of the particles start moving faster. Soon they have enough energy to break free of their rigid structure and move more easily. At this point, matter becomes liquid. Ice melts when kept at room temperature, and its temperature remains constant till the melting is complete. The temperature at which a solid completely changes into a liquid is called its melting point. Different substances have different but fixed melting points. Now, solidification or freezing. The change of state from liquid to solid by the release of heat is called freezing. It is the reverse of melting. The particles in a liquid have enough energy to slide past one another. When cooling takes place, this energy is lowered and particles lock themselves into fixed positions while continuing to vibrate. Thus, the liquid freezes into solid. When molten wax is kept in a bowl, it slowly solidifies while giving off heat to the surroundings. When the kinetic energy of particles decreases, they retain their particular structure and go back to the solid state. Thus, freezing and melting takes place at the same temperature. Vaporization. Vaporization is the conversion of substance from liquid state to the gaseous state by the absorption of heat. It is of two types, boiling and evaporation. Boiling. When a liquid changes into gas by the absorption of heat is called boiling. At a fixed temperature called the boiling point, the liquid particles gain enough kinetic energy to overcome the force of attraction and begin leaving the surface of the liquid. Gradually, bubbles can be seen in the entire liquid. Water boils at 100 degrees centigrade and alcohol at 78 degrees centigrade. The temperature at which all of a liquid changes into vapor is called its boiling point. Evaporation. Evaporation is a state of change from the liquid to vapor by absorbing heat. It occurs at a temperature below the boiling point. Evaporation occurs faster in a warm liquid than in a cold one. Some particles have more energy than others do. In the same liquid, a few molecules in the interior may have less energy of motion, while the other near the surface gain more kinetic energy and vibrate with greater speed. These particles acquire so much energy that they overcome the bond of attraction and leave the surface of the liquid, causing evaporation. Evaporation continues even when a liquid is at normal temperature. Evaporation causes cooling. As we have discussed some of the examples earlier, it is during the evaporation, particles absorb heat from the surroundings, causing cooling. For example, the water in a surahi, or a dog hanging out their tongue, or the clothes in the sun. Condensation. Condensation is the process of a gas turning into a liquid by giving out heat energy. When a gas is cooled, the freely moving particles start losing kinetic energy and slow down. The force of attraction between the lower energy particles becomes strong enough to hold them together, and the gas begins to condense into a liquid. Dew, fog, and cloud formation are examples of condensation. Sublimation. When a solid directly changes into a gas without changing into a liquid, it is called sublimation. Substances like iodine, naphthalene, dry ice, etc. undergo sublimation. The naphthalene balls that we store between clothes gives off a strong odor, which is an indication that particles are constantly leaving their surface. Deposition. Deposition is the reverse process of sublimation. When a great amount of heat energy is lost, the particles of a gas directly change into a solid, as in the case of frost that forms on the surface of leaves at sub-zero temperature. Other examples of deposition are clouds that form because millions of particles of water vapor form ice at very low temperature. The formation of layer of soot on the walls of a chimney is also an example of deposition. Hope you have understood whatever the concepts we have discussed in this part of the chapter. Thank you very much.